A punch card, Ibm card, or Hollerith card is a piece of stiff paper that contained either commands for controlling automated machinery or data for data processing applications. Both commands and data were represented by the presence or absence of holes in predefined positions. Now obsolete as a recording medium, paper tapes constructed from punched cards were widely used throughout the 19th century for controlling textile looms, and in the late 19th and early 20th century for controlling fairground organs and related instruments. Punched cards were used through most of the 20th century in what became known as the data processing industry. The use of unit record machines, organized into data processing systems, for data input, processing, and storage. Many early digital computers used punched cards, often prepared using key punch machines, as the primary medium for input of both computer programs and data. As of 2015, some voting machines still use punched cards to record data. Punched cards for time clocks and other applications are available from the California Tab Card Company. History. Perforated paper tapes were first used to control looms around 1725. However, the paper tapes were expensive to create, fragile, and difficult to repair. By 1801, Joseph Marie Jacquard had developed the machines to create paper tapes by tying punched cards in a sequence. The resulting paper tape, also called the chain of cards, was stronger and simpler both to create and to repair. Seaman Korsakov was reputedly the first to use the punched cards in informatics for information store and search. Korsakov announced his new method of machines in September 1832. Rather than seeking patents, he offered the machines for public use. Charles Babbage proposed the use of number cards, pierced with certain holes and stand opposite levers connected with a set of figure wheels. Advanced, they push in those levers opposite to which there are no holes on the card and thus transfer that number. In his description of the calculating engine store, Herman Hollerith invented the recording of data on a medium that could then be read by a machine. Prior uses of machine-readable media, such as those above, had been for control, not data. After some initial trials with paper tape, he settled on punched cards, developing punched card data processing technology for the 1890 U.S. Census. Hollerith founded the Tabulating Machine Company, which was one of 4 companies that were consolidated to form Computing Tabulating Recording Company, later renamed the International Business Machines Corporation. IBM manufactured and marketed a variety of unit record machines for creating, sorting, and tabulating punched cards. Even after expanding into electronic computers in the late 1950s, IBM developed punched card technology into a powerful tool for business data processing and produced an extensive line of general-purpose unit record machines. By 1950, the IBM card and IBM unit record machines had become ubiquitous in industry and government. Do not fold, spindle or mutilate, a generalized version of the warning that appeared on some punched cards, became a motto for the post-World War II era. From the 1900s into the 1950s, punched cards were the primary medium for data entry, data storage, and processing in institutional computing, according to the IBM archives. By 1937, IBM had 32 presses at work in Endicott, NY, printing, cutting and stacking 5 to 10 million punched cards every day. Punched cards were even used as legal documents, such as U.S. government checks and savings bonds. The UNITYPER introduced magnetic tape for data entry in the 1950s. During the 1960s, the punched card was gradually replaced as the primary means for data storage by magnetic tape, as better more capable computers became available. Mohawk Data Sciences introduced a magnetic tape encoder in 1965, a system marketed as a key punch replacement which was somewhat successful, but punch cards were still commonly used for data entry and programming until the mid-1980s, when the combination of lower-cost magnetic disk storage and affordable interactive terminals on less expensive mini-computers made punched cards obsolete for this role as well. However, their influence lives on through many standard conventions and file formats. The terminals that replaced the punched cards, the IBM 3270 for example, displayed 80 columns of text in text mode. For compatibility with existing software, some programs still operate on the convention of 80 text columns, although fewer and fewer do, as newer systems employ graphical user interfaces with variable width type fonts. Today, punched cards are mostly obsolete and replaced with other storage methods, except for a few legacy systems and specialized applications. Nomenclature. The terms punched card, punch card, and punch card were all commonly used, as were IBM card and Hollerith card. IBM used IBM card, or, later, punched card, at first mentioned in its documentation and thereafter simply card, or cards. Specific formats were often indicated by the number of character positions available, e.g., 80-column card. A sequence of cards that is input or output from some step in an application's processing is called a card deck or simply deck. The rectangular, round, or oval bits of paper punched out were called chad or chips. Adjacent card columns allocated for a specific use, such as names, addresses, multi-digit numbers, etc., are known as a field. Card formats. The Hollerith punched cards used for the US 1890 census were blank. Following that, cards commonly had printing such that the row and column position of a whole could be easily seen. Printing could include having fields named and marked by vertical lines, logos, and more. General-purpose layouts were also available. Some cards had one upper corner cut so that cards not oriented correctly, or cards with different corner cuts, could be identified. Hollerith's punched card formats. Herman Hollerith was awarded a series of patents in 1889 for electromechanical tabulating machines. These patents described both paper tape and rectangular cards as possible recording media. The card shown in U.S. Patent 395,781 of June 8 was printed with a template and had hole positions arranged close to the edges so they could be reached by a railroad conductor's ticket punch, with the center reserved for written descriptions. Hollerith was originally inspired by railroad tickets that let the conductor encode a rough description of the passenger. I was traveling in the West and I had a ticket with what I think was called a punch photograph. The conductor punched out a description of the individual, as light hair, dark eyes, large nose, etc. So you see, I only made a punch photograph of each person. Use of the ticket punch proved tiring and error-prone. So Hollerith invented a pantograph keyboard punch. It featured an enlarged diagram of the card, indicating the positions of the holes to be punched. A printed reading board could be placed under a card that was to be read manually. Hollerith envisioned a number of card sizes. In an article he wrote describing his proposed system for tabulating the 1890 U.S. Census, Hollerith suggested a card 3 inches by 5.5 inches of manila stock would be sufficient to answer all ordinary purposes. The cards used in the 1890 census had round holes, 12 rows and 24 columns. A reading board for these cards can be seen at the Columbia University Computing History site. At some point, 3.25 by 7 3/8 inches became the standard card size. Hollerith's original system used an ad hoc coding system for each application, with groups of holes assigned specific meanings, e.g., sex or marital status. His tabulating machine had up to 40 counters, each with his dial divided into 100 divisions, with 2 indicator hands, one which stepped 1 unit with each counting pulse, the other which advanced 1 unit every time the other dial made a complete revolution. This arrangement allowed a count up to 10,000. During a given tabulating run, each counter was typically assigned a specific hole. Hollerith also used relay logic to allow counts of combination of holes, e.g., to count married females. Later designs standardized the coding. These cards had 10 rows, each row assigned a digit value, 0 through 9, and 45 columns. This provided for a field to represent multi-digit numbers that tabulators could sum, instead of their simply counting cards. Hollerith's 45-column punched cards are illustrated in Comries, the application of the Hollerith tabulating machine to Brown's tables of the moon. IBM 80-column punched card formats and character codes. This IBM card format, designed in 1928, has rectangular holes. 80 columns with 12 punch locations each, 1 character to each column. Card size is exactly 7 3/8 by 3 1/4 inches. The cards are made of smooth stock, 0.007 inches thick. There are about 143 cards to the inch. In 1964, IBM changed from square to round corners. They come typically in boxes of 2,000 cards or as continuous form cards. Continuous form cards could be both pre-numbered and pre-punched for document control. The lower 10 positions represented the digits 0 through 9. The top 2 positions of a column were called zone punches, 12 and 11. Originally only numeric information was punched, with 1 punch per column indicating the digit. Signs could be added to a field by overpunching the least significant digit with his own punch, 12 for plus and 11 for minus. Zone punches had other uses in processing as well, such as indicating a master record, blank, blank, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, Y, X, 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 0, X, 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 1, X, 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 2, X. XXX3, XXXX4, XXXX5, XXXX6, XXXX7, XXXX8, XXXX9, XXXX blank, blank. Reference. Note: the X and Y zones were also called the 11 and 12 zones, respectively. In 1931, IBM began introducing multiple punches for uppercase letters and special characters. A letter has 2 punches, most special characters have 2 or 3 punches, a few special characters were exceptions. With these changes, the information represented in a column by a combination of zones 12, 11, and digits 1 to 9 is dependent on the use of that column. For example, the combination 12 to 1 is the letter A in an alphabetic column, a plus-signed digit 1 in a signed numeric column, or an unsigned digit 1 in a column where the 12 have some other use. The introduction of EBCDIC in 1964 allowed columns with as many as 6 punches. IBM and other manufacturers used many different 80-column card character encodings. A 1969 American National Standard defined the punches for 128 characters and was named the Hollerith punched card code, honoring Hollerith. For some computer applications, binary formats were used, where each hole represented a single binary digit. Every column is treated as a simple bit field, and every combination of holes is permitted. For example, the IBM 711 card reader used with the 704 709th, 7090 7094 series scientific computers treated every row as 2 36-bit words, ignoring 8 columns. Sometimes the ignored columns were used to contain a sequence number for each card. so the card deck could be sorted to the correct order in case it was dropped. An alternative format, used by the IBM 704's IBM 714 native card reader, is referred to as column binary or Chinese binary, and used 3 columns for each 36-bit word. Later computers, such as the IBM 1130 or System 360, used every column. The IBM 1401's card reader could be used in column binary mode, which stored 2 characters in every column, or one 36-bit word in 3 columns when used as input device for other computers. However, most of the older card punchers were not intended to punch more than 3 holes in a column, so they could not be used to produce binary cards. As a prank, in binary mode, cards could be punched where every possible punch position had a hole. Such lace cards lacked structural strength, and would frequently buckle and jam inside the machine. The 80-column card format dominated the industry, becoming known as just IBM cards, even though other companies made cards and equipment to process them. One of the most common printed punched cards is the IBM 5081 card format, a general-purpose layout with no field divisions. This format has digits printed on it corresponding to the punch positions of the digits in each of the 80 columns. Other card vendors manufactured cards with this same layout and number. Mark Sense cards, developed by Reynold B. Johnson at IBM, have printed ovals that could be marked with a special electrographic pencil. Cards would typically be punched with some initial information, such as the name and location of an inventory item. Information to be added, such as quantity of the item on hand, would be marked in the ovals. Card punchers with an option to detect Mark Sense cards could then punch the corresponding information into the card. Aperture cards have a cutout hole on the right side of the punched card. A 35mm microfilm chip containing a microform image is mounted in the hole. Aperture cards are used for engineering drawings from all engineering disciplines. Information about the drawing, for example the drawing number, is typically punched and printed on the remainder of the card. Aperture cards have some advantages over fully digital systems for archival purposes. IBM stub cards or short cards. The 80-column card could be scored on either end, creating a stub that could be torn off, leaving a stub card or short card. A common length for stub cards was 51 columns. Stub cards were used in applications requiring tags, labels, or carbon copies. Ibm Port A punch. According to the IBM archive, IBM Supplies division introduced the Port A punch in 1958 as a fast, accurate means of manually punching holes in specially scored IBM punched cards. Designed to fit in the pocket, Port A punch made it possible to create punched card documents anywhere. The product was intended for on-the-spot recording operations, such as physical inventories, job tickets and statistical surveys, because it eliminated the need for preliminary writing or typing of source documents. IBM 96-column punched card format. In the early 1970s, IBM introduced a new, smaller, round-hole, 96-column card format along with the IBM System 3 computer. These cards have tiny, circular holes, smaller than those in paper tape. Data is stored in 6-bit binary coded decimal code, with 3 rows of 32 characters each, or 8-bit EBCDIC. In this format, each column of the top tiers are combined with 2 punch rows from the bottom tier to form an 8-bit byte, and the middle tier is combined with 2 more punch rows, so that each card contains 64 bytes of 8-bit per byte binary coded data. Powers, Remington Rand UNIVAC card formats. The Powers, Remington Rand card format was initially the same as Hollerith's 45 columns and round holes. In 1930, Remington Rand leapfrogged IBM's 80-column format from 1928 by coding 2 characters in each of the 45 columns, producing what is now commonly called the 90-column card. There are 2 sets of 6 rows across each card. The rows in each set are labeled 0, 1/2, 3/4, 5/6, 7/8, and 9. The even numbers in a pair are formed by combining that punch with the 9 punch. Alphabetic and special characters use 3 or more punches. IBM punched card manufacturing. IBM's Fred M. Carroll developed a series of rotary-type presses that were used to produce the well-known standard tabulating cards, including a 1921 model that operated at 400 cards per minute. Later, he developed a completely different press capable of operating at speeds in excess of 800 CPM, and it was introduced in 1936. Carroll's high-speed press, containing a printing cylinder, revolutionized the manufacture of punched tabulating cards. It is estimated that between 1930 and 1950, the Carroll press accounted for as much as 25% of the company's profits. Discarded printing plates from these card presses, each printing plate the size of an IBM card and formed into a cylinder, often found use as desk pen, pencil holders, and even today are collectible IBM artifacts. IBM initially required that its customers use only IBM-manufactured cards with IBM machines, which were leased, not sold. IBM viewed its business as providing a service and that the cards were part of the machine. In 1932, the U.S. government took IBM to court on this issue. IBM fought all the way to the Supreme Court and lost in 1936, the court ruling that IBM could only set card specifications. In another case, heard in 1955, IBM signed a consent decree requiring, amongst other things, that IBM would, by 1962, have no more than 1/2 of the punched card manufacturing capacity in the United States. Tom Woodson Jr.'s decision to sign this decree, where IBM saw the punched card provisions as the most significant point, completed the transfer of power to him from Thomas Watson, Sr.